Hey, hi everyone. Welcome back to my YouTube channel. My name is Savita, and I'm back with another exciting and important video. So, guys, in this particular video, we're gonna discuss the remaining part of the LLM knowledge distillation. In the first part, I discuss about the fundamental concept of the knowledge distillation along with the theory and practical. If you haven't seen that particular video, please go and check out with my last video. There I discuss the complete concept of the knowledge distillation. Now in this video, we'll discuss the remaining part of this knowledge distillation. We'll see with respect to the large language model. And yeah, I will show you the theory as well as the practical. So if you don't know, guys, I started with this LLM fine tuning playlist where I have uploaded around 10 videos with respect to the fine tuning. Each and everything I have covered from very scratch. So if you are new to this fine tuning, LLM fine tuning, then definitely you can adapt the concept in a very easiest way. And guys, once you will check out the playlist, along with this fine tuning playlist, you will find out the other playlist also like langchain, langgraph, advanced RAG, multimodal RAG, and the retrieval augment generation, the basic RAG. So if you want to start your career in the field of AI, in the field of generative AI, guys, so my channel could be one-stop solution for all of you. If you haven't subscribed my channel, please do subscribe, or else first check out with the content, then guys, you can subscribe the channel. Now, if you want to connect with me one-to-one, then here you will find out a link. So just click on this link according to your concern, whatever concern you have. Let's say if you want to be get this generative AI preparation material, if you want to connect for the resume preparation, and if you want to connect for the interview tips, for mock interview, each and every service is available over here. So you can book a slot accordingly. Now, guys, without delaying in the video, let's start with the concept. Let's discuss that what all thing, what all point I'm going to be discussed specifically. So here, guys, all the points which I capped inside my OneNote. Let me open that first, and let me go ahead with all the points. So in the first video, in the first part, I discussed about the knowledge distillation. Then I came to the concept of the teacher and the student model, and then I showed you the distillation in the neural network. I covered both thing theory as well as the practical. In the theory, I discuss the mathematical concept behind this distillation, and even I discuss about the important research paper in terms of this distillation. Now in today's video, guys, in this particular video, we're gonna discuss about the distillation in a large language model. I'll show you the practical. I'll show you like how this distillation was possible in a large language model. We'll show you the formula and all. Then I will discuss about the normal fine tuning versus distillation. Then where to use this distill model. Okay, what is what is a specific area where we can use this distill model. Then, guys, I'll come to the overview of the DeepSeek distill model. I'll show you this state-of-art model, this DeepSeek model, and I go through with the training process of this DeepSeek model, and we'll discuss about the distillation concept also with respect to the DeepSeek. I'm not going into the depth means the mathematics and all, because this will be a separate playlist. So I will record this DeepSeek playlist in my upcoming videos. Okay, in my upcoming days. Today I will just give you the overview so that you could be familiar with the LLM knowledge distillation. Now let's do one thing, guys. Let's try to understand distillation in a large language model. Then we'll come to this normal fine-tuning versus distillation and where to use it. And at the end, I will give you the overview of this DeepSeek distillation models. Okay. So here, if you will go and check with the first part, so there I kept the entire theory. So the distillation definition, what is the definition of the distillation? And here you can see where it is being used. So this point I can explain you later on. Then I showed you the concept of the teacher model. What is a teacher model? What is a student model? Okay, I given the complete definition with respect to both. Then I discuss one loss function. The loss function basically which is being used in a distillation. So this was the entire loss function, guys, this one. So here we are having two things. First is a cross entropy and the second is a KL divergence loss. Okay. Now apart from that, I discuss about the hard level. What are the hard levels? What is the soft levels? Okay. and I given you one real time example also. So I took some like values, I like kept some arrays values and all, and with that I tried to explain you in terms of the real time. Then guys, here I kept couple of diagram as well. So the diagram basically for all of you only. So with this particular diagram, I try to explain the concept of the knowledge distillation, that what it is. If you don't know about it, guys, you can check out with my previous video. Okay. Now here, guys, if you will check, if you will see, so I explained the complete training process also. So if we are going to be trained in a neural network, what will be the training procedure of it? Means first we'll pass the input, then it will go to the hidden layers, then it comes to the output layer, and then we try to figure out the loss. So loss plays a very important role over here, and using this loss function only, we are going to be train our model. Means our main motto is to minimize the loss in any sort of a training, and for that we are going to be use the back propagation technique, where we are going to be differentiate the loss function itself. So this is the basic optimizer, guys. This is the gradient descent optimizer, and here you can see we are going to be differentiate the loss. Okay, so loss plays a very important role, and inside this distillation we are going to be change our loss function. Okay, and with that only we are going to be distillize the knowledge. Distillation means what? From the large model itself we are going to be pass the knowledge to the small model. Okay, large model is called the teacher model, and the small model itself is called the student model. Okay, so this entire thing I explained in my previous video. If you don't know about it, you can go and check out. Now one more thing I have to tell you over here. So guys, here if you will see, so let's say we are giving any sort of an image to the neural network, okay, or any sort of a data to the neural network, so it will predict the soft level. Soft level is what? Soft level is a probability. Okay, so if we have a multiple classes, so with respect to the multiple classes, it is going to be predict the softmax value. It's going to be predict the probability value. Okay, and then it is called the hard level. Hard level means what? So let's say here is a probability from the softmax 0.7, 0.2, 0.1. So the probability for this particular value is very high. Okay, so here we'll place 1, rest of the value is going to be 0. So 1 to whatever basically image to whatever data point we have assigned this 1. Okay, so that will be my final prediction, something like that, right? So this entire process I have explained in my previous video. If you don't know about it, guys, you can go and check out there. So this was a quick recap, okay, from the previous videos. Now coming to the next part. So here, if I'll show you the next part, the LLM distillation. So this LLM distillation also, we are doing this knowledge distillation inside the large language model. We're gonna perform using the same formula itself. So this is the step-by-step notes, guys, which I prepared to all of you, and for sure I will provide all the notes. I'm getting like some comments in my comment box that sir, some of the notebook we are not able to open. So my one and only suggestion to all of you, please download that particular notebook inside your local system and then open it inside your system. It will be opened. Okay, if you're not able to do it, guys, what you can do, you can download it inside the local system and then you can upload it over the collab. In that case also it's going to be open, right? So both things you can check out. Now let's see what is the core behind the LLM distillation, which formula we were using. Okay, let's try to take a recap of that particular formula, and after that, guys, I'll show you the practical. So guys, whenever we are going to be distillize the knowledge from teacher to student model, from a large to small model, so that particular loss function plays a very important role. So first of all, let me do one thing. Let me give you the outline. So teacher model is a huge model. Okay, the big model is called the teacher model. Let's take an example. So if I'm saying Bert large model, Bert large model is a teacher model, and this Bert small model is a student model. Bert student model is going to be a, sorry, Bert is small model, not a student model. Bert small model is going to be a student. So from here to here, we have to transfer the knowledge from where to where, from Bert to Bert large to the Bert small. So what we are going to be do, guys? So how we are going to be how we are going to pass the knowledge from Bert large to the Bert small. So here is my Bert large model. You can think in such a way. This is my large model. I can write large, and here is my small model. Okay. So this Bert large model already have been trained on some data. This data is going to be a large data, huge data, anything you can say. So during the training, guys, it has learned some pattern. Okay. So during the training, when it was going to be predict the output of the given entry or given data point. So it is going to be predict some softmax value. Okay. Softmax value. Now this softmax value, we take this softmax value. Okay. So whenever we are training this small model, we pass the data. Okay, it's going to be predict guys. What's going to be predict? It's going to be predict some softmax value. Okay, and how we find out the loss? So we find out the loss between this value, and this value. So we find out the loss between this value and this value. So this is a simple meaning, right? This is a simple meaning, guys. Here is a simple meaning to find out a loss between what? Between the softmax itself. Okay. Now we find out one more type of loss. So the regular cross entropy loss. So here is my predicted value, and we will be having hard level also. So between that also we are going to be figure out a loss. Okay. So these two loss we are going to be calculate. The first loss between this softmax value and this softmax value, and another loss between this softmax value and this hard value. So this is called my distillation, knowledge distillation, from where? From this large model to this small model, in terms of what? In terms of the softmax probability. And here we are going to be learn using this special loss function. The loss function basically it's going to be a combine of the scale divergence as well as this cross entropy. That's it. Okay. So between these two softmax, right, we are going to be check a loss. We are going to be check a loss using this scale divergence method. I hope this is clear. So here I kept some point for all of you. You can read out this point. It will help you a lot. So here, let's say we have a data. So the data name is what? Stanford Sentiment Tree Bank B2, SST2. So this data, it's containing some. It's going to be contain some sentiment classification data. Means it is having some movies. It is having some movie sentence, and regarding that you will find out a label whether it's going to be a positive or negative. Okay, so positive means 1, negative means 0. So guys, here let's say here I have written the teacher. Basically it's going to be predict the soft label. Student, it's going to be learn from both soft label as well as the hard value, right? So the second one is what? TX. TX means what? Output logits from the teacher model. SXP means what? So output logits from the student model. So this logits is nothing. It is a softmax value. Okay. So this logits is nothing. It is a softmax value, right? So this logits, this one is this one. Okay. And this logits, this one, soft level is this one. Okay, so this is from what? Where? This is from the student model, and this logits from where? From the teacher model. And this is nothing. This is just the value of the softmax. Okay, whatever softmax is going to be predict in terms of the probability distribution. Okay, now here guys, if we're talking about the formula, so here is the final formula. This one. Combine both losses, final destination loss. Using this particular loss only, we are going to be train our model. So inside this particular loss function, you will find out, see, here is a cross entropy. Okay, L means what? Loss cross entropy, 1 minus alpha, and here loss scale divergence. So this is the loss, this is the cross entropy, as you know the cross entropy. So this is my level, okay, and here is my softmax value. This is my cross entropy loss, this one, right? So how to like find out a loss, this cross entropy loss? If you remember guys, see, let's say if we have a dog image, this particular dog image we are passing it to the network. Okay, now this particular network it's going to be predict some softmax value. Okay, So this is going to be predict some softmax value. Let's say this is 0.7, this is 0.3, this is 0.1. So here you can see what I'll be getting. I'll be getting 1, 0, 0. Okay, so 1, 0, 0. And what was the actual level? What was the actual level? What was the actual level of this dog? The actual level of the dog was 1, 0, 0. So here you can see, guys, this is my predicted level and this is my actual level. Okay, so this y is nothing. Yi is nothing. It is a this hard level, hard value. Okay, this is called the hard level. Okay, this 1, 0, 0, and this is called the soft level. Okay, soft level, LEBL, and this is called the hard level. Getting my point, guys? Okay, so here what will come? Here this probability will come. This probability, see, softmax of Sx. Okay, this probability log of it, and here would be my hard level. Okay, so something like this, we calculate the cross entropy. In the deep learning videos, we can understand more about it. Now here, guys, you can see what we are doing. So here we are going to be find out the loss, this KL divergence loss. Okay, what's the full form of the KL divergence? We'll try to discuss about it. So inside this KL divergence, what we have this T means temperature, the summation. Okay, PT means what? Here is the probability of the, here is the probability of what? Probability of the teacher, and the log probability of the teacher and probability of the student. So this particular KL divergence loss function is completely dependent on this softmax values. Okay, now here again you can see T is a hyperparameter, temperature value, right? Now here you can see summation of what? Probability. Okay, and here you can see log probability of what? Teacher divided by probability of the student. And how we are going to be find out this probability? Like this one. Okay, we are going to be normalize it using the temperature. So this is the same function, same loss function we have seen in the previous video itself. So you just have to remember that in the final distillation, whenever we are talking about the knowledge distillation, we use this combined loss function where we have a KL divergence as well as this one, cross entropy. Okay, so the loss function is a combination of this both. I hope this thing is clear. Now coming to the next part. So guys, here if you will see, so we have a transformer architecture, and see the second architecture is representing to the LLaMA model. Okay, so this LLaMA, it's a predictive model. It's a predictive model, or I can say this is a generative model. Generative model. So it's going to be generate the next word. It's going to be predict the next word inside the like in the given sentence. Whatever sentence we are giving is trying to predict the next word. Okay. Now here, guys, this LLaMA, it is based on the decoder. Okay, it's a decoder architecture. This decoder is also called the GPT, generative pre-training. The main use case of the GPT is to generate a word, to generate a future words, future sentences. Okay. Now inside this LLaMA, you can see what we have. We have an input. So here is my input. Then we have an embedding. Then here you can see we have a self-attention block. After that we have a feed forward, right? So in between, like some processes going on, this normalization process, and then here you can see some escape connection and all. And after that, we are going to be linear the like the output, and we are going to be apply the softmax. So the softmax value itself is called the soft label. Okay, so this is the probability distribution. This is also called the probability distribution, and the softmax value itself is called the soft label, and it's a probability distribution. Probability distribution regarding what? It's a probability distribution regarding the regarding the given input. Okay, so I hope this thing is clear. We can look into their mathematics and all in some other classes. As of now, I'm just showing you that okay, this is the architecture, the LLaMA architecture. Similar to that, we have a Mistral architecture, GPT architecture, Cloud architecture, DeepSeek architecture, all the state of art model. Okay, this generative model, it depends on the transformer architecture itself, and this is one of the example. And why I kept this example, so that you can understand that it is going to be predict this softmax value at the end. Okay, really we are getting a soft level at the end. I hope this thing is clear. Now coming to the next part. So, guys, if we're talking about the distillation, so guys, if you have seen my previous video, if you've gone through with that, so distillation is nothing; it's just a process, right? We are going to be train our student model again. Okay, so either that student model is already trained, means we are going to be fine tune it on top of the softmax value which we are getting from the teacher, or we just initialize the student model and then we are training it using those softmax value itself. So this entire concept I have clarified in my previous classes itself, previous videos. Mainly in the previous video, if you haven't checked, please go and check that specific video. It's very, very important, right? So in that only you are going to be building fundamental with respect to the distillation. Now guys, here if we're talking about the distillation, so distillation is all about to this loss function, okay? And here is the entire process. If you are facing difficulty to understand this entire process, means you need to check out the previous video. Now coming to the next part. So here I have written some facts. So the first fact is DistilBERT. Okay, a distill version of the BERT. So we are going to be create our own version in today's video. So DistilBERT has a 40% fewer parameter and run 60% faster. Okay, because it's a small model. So it's still retain 97% of the BERT performance. So whatever BERT is going to be predict, right? So it is 90% accurate. Okay, means if let's say BERT is 100%, then it is able to perform the 90% of that BERT model. Getting my point? Now here guys, you can see DistilBERT has 40% few parameters, 60% faster, right? So it is as much as BERT accurate, but it is slow, it is faster, as well as having a less size. Okay, so that's the power of the distillation. Means we can utilize a student model on a same level where we have that main model, the larger model. Now here you can see the second fact. So 770 million T5 model outperform 540 billion Palm with just 80% training data. If we are giving that 80% training data and we are training and we are taking a soft label from the Palm, okay, that softmax value, and we are going to be train this T5 model, a very small model. In that case also we are able to achieve, right, a good accuracy. Getting my point, guys, how powerful this distillation could be. Now the next one is a tiny llama. So tiny llama model trained on just 1/40th of the token can match performance of the full llama model. Okay, so again this is the example of the distillation. So distillation, quality tokenizer, data curation, and we are getting a beast model. Beast model means the model basically which is a smaller, the model basically which is having a fewer parameter, but still it is able to do a very great job, right? So that's the power of the distillation, and this all the facts are not just a fact, it's a truth, guys. Yes. Okay, now what you have to do, so after learning this much of thing, after learning this much of theory, and if you have seen the previous video, the fundamental and all, then you should move to the practical. Okay, so here I kept the complete practical. Let me show you that particular practical, guys. And see all the the code and all, everything you will find out over here, and for sure I'll run it in front of you only. Now apart from this one, guys, here I kept couple of research paper for all of you. So let me go through with that specific research paper the first place, then I will come to this particular implementation. Okay, so here guys, you can see the first research paper as I shown you in my previous video itself. So the first research paper basically distill the knowledge in the neural network. Okay, the second research paper, it is very much important, and for sure you should read this research paper. Most of the part basically I took from here itself. A knowledge distillation a survey. Okay, so the architecture which I taken in my previous class, so I take a reference from here. Now teacher model, knowledge transfer, student model, and I created one mimic architecture behalf on this. Now apart from this one, guys, you can see it is having a very good visual representation, and they have explained the distillation in a better way. Okay, along with all the benchmark data, formulas, and all. So what I shown you, this those thing was just a replication of this research paper, and it is it's very important, guys. If you will go through with it, you will learn many new things. Now apart from this one, one more research paper, DistilBERT. I think we all know about the DistilBERT. It's a distillized version of the BERT, right? So how it has been trained, what all like thing is it is able to perform each and everything you will get inside this particular research paper. So this is again one of the mandatory thing for all of you. You have to go through with this. Now one more research paper, guys. So tiny stories, how a small language model can be like very powerful. Okay, so this thing have been explained inside this research paper. for sure you should go through with it, and you will learn many more new things once you will read out at least heading of this research paper. Okay, heading, introduction, abstract, and all. Just read out all these three things. In that case, like you will get a like good overview of this research paper. Then later on you can deep dive into the mathematics and all. So here is one more research paper, guys, which is the important research paper. Please skip all this research paper, but don't skip this particular research paper. Okay, because whatever distillation you are seeing, right, it depends on this research paper, distillizing step by step, outperforming large language model with less training data and smaller model size. So whatever training you will see with the respect to the large language model, okay, like the distillation of the large language model, so all the thing, all the benchmark, everything have been like mentioned inside this research paper, and this is the mandatory and important for all of you guys. So you can skip rest of the research paper, but don't skip this one. It is very much important. Now let's do one thing, guys. I will come to the other points on a later on. Okay, so how we can fine tune using the auto train. Okay, or else like what all model we should explore with respect to this distillation and all. Everything I kept for all of you along with different facts. So we'll try to discuss each and every part of it. So first of all, let's look into the basically practical. Okay, and then we'll come to this specific part. So at the first place, guys, we'll have to connect with the runtime. So click on the runtime and then select the GPU. Change runtime type and then select the GPU. Okay, click on save. So here you can see at the first place we'll have to install this library. First is the dataset. Second is this FSSPEC, then transformer. Now why we use this FSSPEC? So this particular library, using this particular library, basically we can access the data from any sort of places like S3, GCP, Azure, okay, from any GIF file, from any server, right, from anywhere. Okay, so it allows to Python program to read, write any file, okay, using the same interface. So we can open file, we can read file, we can write file, anything. So now guys, see what we are doing. At the first place, we'll have to install it. This command is pretty much mandatory. Otherwise, you might get an error with respect to this package and all. So please execute this command if you are going to perform this particular implementation. Then after what I will do, I will execute this import warnings. So whatever warning is coming with respect to any package, so I will filter out or I will ignore that particular warning. Now after that, I have a couple of more statement, import statement. So here I'm going to import the torch. From torch, I'm going to be import the neural network, then optim. Okay, this is for like importing the optimizer, the data set, then transformer. The data loader is there, then load data set is there. Okay, data loader basically to load the data in a HuggingFace compatible format. Then we have this load data set for loading any data set from the HuggingFace. Then auto tokenizer, okay, for loading the tokenizer. A data collector with padding, so to perform the padding to keep the data uniform. Okay, even the train and validation test, whatever data we have, right? The data loader is a redundant one, so I will have to remove it. Let me remove this one. Now guys, here is some parameter which I defined, which I mentioned. So batch size would be there. So in how many batch, in one batch, how many data points would be there? Then here is a learning rate. So what is the meaning of this 5e minus 5? So 5 into 10 to the power minus 5 means 0.00005. It's a very small learning rate, as you can see. Then we have a epoch. So one epoch only. It is just a testing. So I'm just going to be execute one epoch. But if you are running it in a real time, then you can run it for as many as epoch as you want. So it is just a hyperparameter. The temperature value, again, it is a part of that loss, the knowledge distillation loss. Okay, the temperature value I'm keeping 2. There would be range of it. I think 2 to minus 2 to 2. Okay, we'll check about it. Then alpha soft, again, it is a value of for that formula itself. Then maximum length, okay, the generated output. Now here you can see the device. So device basically this maximum length, I think, for the sentence, okay, for one specific sentence, not the generated output. So it is for one specific sentence, like which the sentence which we are getting the data now, right? And then further we are going to be tokenized, and then we are going to be perform the training on top of that itself. So here, I think this all the thing is clear. Now what I'm doing after loading all this parameter, I'll load my data. So I'm going to be load this tweet eval data. It's a sentiment data. Okay, I'll get inside the variable raw. So here what I will do, I'll take the label from here from the raw data, raw trend data, and see I have three label. First is a negative, second is a neutral, and third is a positive. Okay, so let me show you the label. Let me print it. And here, guys, what I'm doing. So I'm printing the labels. So yes, we are able to do that. Now for the training, I'm taking a subset of the data. So I'm just taking 2.5K sample from the data itself. I don't require the complete data because it is very huge, and I might get like it might get some time, right, while it is training the model. Okay. So we have to take the subset of the data. Now what we'll do for the validation also, we'll take our data. Okay, so for the validation, we can take the entire data, and here I written the explanation also that why we are doing it. So why trade is subset but validation is not? So training cost is high, validation cost is low. Training basically it takes much time on top of the huge data, and the GPU cost also is going to be also going to be very huge. So we take training data as much as lower one. As of now, we are in like learning phase, testing phase. So we'll take a very less training data. But if you're working in a real time, then you can arrange some more configuration and all, and on top of it, you can train your model. Okay, with the huge data. But yeah, for the validation, we can take as much as data, and here training is not involved, so it won't take much time. Now here, I hope everything is clear. So what I will do, I'll initialize my tokenizer now. So which model we are going to be considered? So we are going to be considered two model. The first model, Bert large model, and the second one, Bert base model. Okay. So I'm going to be load the tokenizer for with respect to what? With respect to this Bert base model. Okay. Now what I will do, I create a function. So this function, what it will do, it will take a text. Okay, it will truncate that. It will convert into the max length, means it will keep the max length which we have defined. Okay, with respect to the sentence. So here is my tokenizer, then here is my list, here is my dictionary. Now inside the dictionary, basically I will keep both training and validation data after the tokenization. So let me run it, and the entire data will be there after the mapping, okay, after the tokenization. So if you will check out with this particular dictionary now, if you will take this particular variable and print it inside the new cell after this mapping, so you will get a detail. Okay, so let me show you. So here, guys, you can see we have a tokenized data. So train data as well as what? As well as the validation data. Okay. I hope this thing is pretty much clear. So model wise, I'll come to the model that which one is my teacher model and which one is my student model. Okay. Now what we are doing, guys, so here we are going to pass the data, this tokenizer to this data collator with padding, and here I am passing two variable. First is a tokenizer, second is a pad to multiple of, okay, and here I am passing one variable value 8. Okay, so let's try to understand what is the meaning of it. I kept the explanation over here inside the markdown. So the meaning is very simple. So it creates a data collector. Okay, so it automatically pads all the tokenized input in the batch, means let's say we have a sentence. In one sentence we just have, so I can explain you this thing. Give me a moment, guys. I'm going to be explained. So in one sentence, or let's suppose we have 5 tokens. So this is the ID with respect to the tokens. 1, 2, 3, 4, and let's say 5. Now in another sentence, we have 7 tokens. So 2, 6, 5, 7, 10. Okay, then here will be what? Here will be, let's say, 11 and 16. So I have how many tokens? 5, and inside the second sentence we have 7 tokens, right? So we'll have to pad it. We'll have to pad this particular sentence. So while I'm going to be generate a padding of it, so here I will write 0, 0. Then after that, this 1, 2, okay, this 1, 2, 3, 4, 5, it will be as it is. So here will be 1. Here, basically, I will be having 2, then 3, then here is 4, and then here is a 5, right? So this is called padding, and using the data collector, we are doing this particular padding. I hope this is clear. Now, see, automatically it will perform the padding, and here one more parameter is there. Why pad to multiple of 8? So I written an explanation. So 10 tensor cores in GPU are optimized for data size that are multiple of 8, 16, 20. Means the data size should be multiple of 8. Multiple of 8 means what? 8, 16, 32, okay, then 48, then 56, 64, something like that. So multiple of 8, okay. So 8, 16, 32, 40, 48, correct, then 56, okay. So padding to multiple of 8 help faster training, better memory alignment, and reduce state mismatch error in mixed precision. So this is the explanation of these two variables. So you can imagine in such a way, let's say you have a 3 tokens, okay. Imagine you have 3 tokenized input of length. So the first, basically in the first sentence you have 5 tokens, second 7, and then 11. So with pad of multiple 8, you will be doing like this. Means you are going to be padded, you are going to be like map it to the nearby value. So 5 will become 8, then it will become 8, it will become 16, okay. Means we have 5 token, 7 token, 11 token. Here you can see 8 token, 8 token, and 16 token, something like that. It is just tested, okay. Someone is tested with the rigorous testing and all, and then only they are able to make this particular conclusion, right? Now we have a data collector. So let me do one thing, let me execute it, and here is my train DL. So I'm going to be like convert my data into the HuggingFace data compatible format. So I'm passing my data, train data. Here is my best size. Here shuffle is equal to true. Then data collector function. Collector I will be passing this collector, right? So here I am getting train data, and here is my validation data. I hope this thing is pretty much clear to all of you. Now coming to the next part. So now guys, what I'm doing, I'm going to be load my model. So the first one is a teacher model. So I'm going to load this Bert large model as a teacher model. As I told you, this large model is going to be my teacher. Again, there's a small model, Bert based uncased model. This is a small model. This is going to be a student model, right? So teacher and student both I have. Now what I will do, so here I will freeze, okay. So I will trade on top of the all the parameter of the teachers dot parameter. I'll get the parameter in this p dot require gradients, and here I'm keeping false, okay. Means I don't want to train the teacher parameter, okay. So once I'll run it guys, I will be able to freeze all this parameter. Now coming to the next part. So I will put this teacher on a evaluation mode, okay. So I will not going to be perform a training with respect to my teacher model, okay. Put the teacher mode in evaluation mode instead of the training mode. So I'm not going to perform the training, I'll put it over the evaluation mode. Then here is my loss function. This is my cross entropy loss, okay. This is my KL divergence loss. Now what is the full form of this KL divergence guys? So the full form you can see Kullback Leiber divergence. So this name, it is based on the scientist, okay. It's a scientist name, Kullback Leibler divergence, okay. So which is called KL divergence loss. So here guys, one more loss we are going to be defined. So here is a cross entropy, and here I'm going to define the KL loss, okay. Now what we have the optimizer also. So here you will see the optimizer. So we are going to be use this Adam optimizer. Now what is the meaning of the W over here? So I written a explanation over here. So optim dot Adam W means weight decay. So it's a popular optimizer used in a transformer based model like LLMs. So it combines Adam adaptive learning rate plus momentum, and as well as a weight decay, okay, regularization to prevent overfitting. This weight decay value. So this is just this is all the mathematical explanation and all, okay. It's just a mathematical parameter. Regarding that, we'll have to understand the proper mathematical derivation, right? So what is a Adam, why we use W, weight decay and all. As of now, I'm just giving you the terminology, the idea behind each and every terms and terminology. That's it, nothing else guys. Because this topic, it is not an easy one if we are exploring it over the mathematical level. So that mathematical level will come later on once we'll discuss the deep learning based concept, this optimizer and all. Okay, then only we can understand the formula, the mathematics, and we can put some value, we can make a calculation and all. As of now, we're just trying to understand on a high level this entire terms and terminology. So if you're going through with the practical, so easily you can understand that part. Now coming to the next part. So here I'm going to define my optimizer. So what I'm passing, guys, I'm passing my like this. I'm passing my student parameter as well as this learning rate. Okay. So here is my optimizer, because we have to train the student weight only now, right? We are not going to be train the teacher weight. So that's why I'm passing the student dot parameter only. Now get scheduler, guys. So this get scheduler for what? This get scheduler for defining the learning rate. Okay. So to this get scheduler, we are passing this linear optimizer number wrap up step 0 and then number training step length. So what is the meaning of it? Here you can see. So you are using a learning rate scheduler. Start with a high learning rate. Okay, gradually decrease linear to 0. No warm up, nothing. Okay, you can keep the high value only. Okay, start with a full speed initially. So here is all the parameter. Name linear means use linear decay scheduler. Optimizer would be the ADAMW. Num wrap warm up step. Don't warm up. Start with a full capacity means the highest learning rate. And here number training step. Okay, so total number of step in training loop. So the graph will look like something like this. If we are talking about what, guys? If we're talking about the learning rate and step, right? So the learning rate will be high at the first place, then it's going to be drop. Linearly, it's going to be drop. See, you can clearly see inside this specific graph. Now coming to the next part. So here is my learning rate LR scheduler. Okay, I'm going to be schedule the learning rate, and then what I will do, guys, see here I'm going to be initialize this TQDM just to check the progress. Okay, so this is my specific loop which is responsible to perform the training. So this still epoch is there. Okay, this is my function. Now I am calling this student.train. Okay, so this student.train, what it will do, it will like initialize the training, okay, with respect to the student model. Here I'm going to initialize the progress bar. Okay, then I'm going to be iterate on top of this progress bar, means I'll get badge. So from the badge itself, I'm going to take this ID, attention, and labels, this 3 things. So with respect to teacher, we are not going to perform any sort of a training. We are saying torch.no grade. What is the meaning of it? The meaning is very, very simple. Means we are not going to perform any sort of a training over here. So teacher will take input as it is, and it will provide the logits. Logits is nothing, it's a softmax value. Okay, as you can see, we are able to get the softmax value. Now using this value as well as the softmax value of the student, we are going to train this model. So we are getting a softmax value, the predicted value from the teacher. Okay, we are not going to perform any sort of a training. Then student, what it is giving, again it is giving me a softmax value. Okay, so first we'll design our cross entropy loss. So here you can see, guys, sorry, first we'll design our KL divergence loss. So this is my KL divergence loss, as I shown you the soft level, okay, from the student, from the teacher. And here you can see the temperature value, which is hyperparameter. Now here is a hard loss basically in the student model itself. Okay, and this soft loss, again it is in a student model, but one value is coming from the teacher model. One softmax value is coming from the teacher model. Okay, so this is my proper loss function, the perfect loss function. Okay, then here is a optimizer. We are going to be initialize the optimizer loss. We are going to be calculate that optimizer. Okay, and then here is my learning rate schedule. Once I will run it, guys, here you will see it is running successfully. Now the further code for the evaluation. So we are going to be put my student model on a evaluation mode. Okay, and here we are going to be fetch this particular value, then we are going to predict the outcome. Okay, and then we are going to be return the accuracy. That's it. So here is my evaluate method. So we are going to be evaluate our model, okay, on top of the validation data. Now over here, guys, you can see we are going to be validate the data. Okay, so my data is going to be validated, and sorry, my model is going to be validated. Now after that, what I'm doing, I'm going to be save the model. Okay, so what I'm doing, guys, sorry, this is the training one. This is the training one. The training is started, right? And it will do the validation also, this evaluation also. Okay, evaluation also. This is the training process. So I'm going to be called this distill epoch. So distill epoch, once it will call the distill epoch, so my training is going to be started. Means I'm going to be find out our loss, then backward propagation, the loss, backward propagation. So my entire training is going on, and here I'm calling this function distill epoch. Then evaluation. So after the evaluation only, I'll be getting the final accuracy, and that particular accuracy will be present over the console. Now coming to the next part. So here we have the next method where I'm going to be save the model. So save dot pre-train. So I'm going to be save the distill model. So this distillation have been done on top of the BERT model. Okay, so you know the DistilBERT model. So that was trained by some community, some researcher and all. Now this particular model, this DistilBERT, we have trained by ourselves. Okay, you can train your own model to run it on a small device in small configuration with a faster inferencing, right? So we are able to save the model. Now what I will do, I'm going to be tested the time, the accuracy between the normal model as well as the distill model. Okay, so here I'm going to be load the test data. See, this data is from the same repo tweeteval. So I'll be getting the test data. I'm going to be tokenize it. Now here I'm going to be set the format and my data is ready. So I'm going to be prepare all the I'm going to be prepare the entire Hugging Face compatible data. Now here is my predicted and evaluation. So I will get all the prediction over here. We are not going to perform any sort of a training. We'll get an input. From this input, we are going to be fetch this value. Then we are going to perform the prediction over here. So I will check the time. I'll check the accuracy between what? Between two model, teacher and the student. Okay, whether they are going to work in a same way or having some differences in between. So here what I'm doing, guys, I'm going to be executed. Now after that, I'm passing this teacher model as well as the student model. And once I will execute it, so after the execution, guys, you will be able to see the time, how much time each model is taking, and the accuracy as well. So here you can see the distill but accuracy is coming more than BERT model, and BERT is taking around 3.96 second, as well as the apart from this apart from the BERT, guys, you can see the distill it is taking 1.26 second. It is very small time, right, as you can see. So as well as it is giving me a good accuracy. Now in your mind one question will come, can this student model give the more accuracy than this teacher model? Yes, this is possible. So here I written a couple of points to justify this thing. So distilling step by step. Okay, a 7 million T5 student outperformed PALM for 540B teacher model. Means inside the teacher model they were having 540 billion parameter, but guys, one T5 model with the distilled knowledge was outperforming to this PALM model. Now here you can see the tiny bird. So task specific distillation allowed tiny bird to beat bird. So in some cases also this tiny bird was beating the bird, but this tiny bird was the distilled version of the bird itself. Then here, guys, you can see the reason explanation. So tweet eval, basically why we are getting a much accuracy in the distill model. So there could be a few more reason. I mentioned those particular reason over here. So tweet eval is small noisy data. So BERT large is overfitting or underconfident. Student is fine-tuned. You updated student weight on 12 bag task, right? So again I perform the training, the fine-tuning, okay, on top of the already trained model, right? And how we have performed this particular training? We have performed using what? Using those teacher laws, right? Teacher soft values. So distillation is a special kind of fine-tuning, guys, you know. Okay, so many time I have repeated this part in my session. So teacher is frozen. So you are using teacher as a frozen, right? Teacher not task specific. Your BERT large is general, but student is a task specific. That's why we are getting a good accuracy. That is still means we are getting a good accuracy than this large model. Okay. So I hope this is pretty much perfect. This is pretty much clear to all of you. Now here you can see teacher accuracy, student accuracy. There might be this much of difference as well. Okay, so here I given some comment only. So you just need to be remember this reason and explanation whenever you are appearing in any sort of an interview, so that if someone is going to be asked you the question related to the quantization, distillation and all, it's going to be clear completely. Okay, so I hope this is clear. Now I will give you the walkthrough of one LLM model, the classic, the latest LLM model. Okay, maybe I will not be able to execute this in my local because I don't have that enough RAM, but yeah, for sure I'll give you the recap. I'll give you the revision of it, that what all thing I am doing here, and so that later on you can perform it from your end. So now what I have to do, guys, so first of all let me show you some theoretical point, then I will come to this particular. So if you will see here, guys, we are able to train this DistilBERT model, okay, and the teacher model was the BERT. Now let's do one thing. Let's take some state of art model. State of art model means what? State of art means this part actually it's a classical large language model. Okay, it's not a state of art. So the state of art model means GPT, Gemini, Cloud A model. Okay, Sonat, and DeepSeek, Llama, Mistral. Okay, JFrust. So these all are the state of art model, right? So inside this one, the latest technique, the latest basically mathematical concept have been used to train it. GPT 4.5 coin model is there, right? DeepSeek R1 is a very good model with respect to the reasoning. So and Phi is one of them from the Microsoft. It's a very good model, right? So this model is a state of art model. Now here I kept one more example with respect to that a specific state of art model. So I kept a different ID. So see guys, I'm using a free variant of the collab. Inside this variant, I'll get a very limited resources. As you can see right hand side, I'm getting a resources around 12 GB of RAM, and I hope it is visible. Let me scroll down, or let me switch off my camera so that you can clearly see. So guys, if you see over here, so the resources was 12 GB of RAM, okay, 15 GB of GPU RAM, which is called VRM. Then a disk is around 112 GB. So this much of configuration is not required for loading this specific model. Okay. So here guys, if we are going to be load this llama model, the memory is going to be crash instantly. If we are going to be load this if we are going to be load any Mistral model, okay, which is having 7 billion parameter or even 3 billion parameter, then also memory is going to be crash. This tiny llama will be able to load, but again, training will be very tough. So I kept this ID. If you have access of the Google Colab Pro or any other cloud platform, then for sure you can try out with this one. So which model I have used? So let me show you the specific model. At the first place, I'm going to be install this transformer, accelerate, and bits and bytes. We cannot use the quantized model over here. We can use it guys, but with the quantized model having some issue with the small data, we'll have to take a very huge data in that case. Okay, so I'll show you this particular distillation with the floating point 16. Okay, with the FP16 precision, and here for that I already written a code for loading a model. Okay, so at the first place this library would be required. Even I tried with the post-aware quantization, means we already have a trained model, but whenever we are going to be load in a memory, we can load it in a lower precision. Okay, if we have trained it with the FE32, FE16, FP8, then we can load it in int. Okay, int 4, int 8, NP. Okay, so this quantization we'll discuss in a next video. So here guys, you can see, so we are able to load, we are able to install all this thing. Now I am going to be import this particular import statement. Then the teacher ID is a Microsoft Phi 2 and the student ID is a Phi 1 underscore 5. Okay. So here what I'm doing, at the first place, we are going to be load the tokenizer. So this is the code for loading a tokenizer, as you can see over here. So let me execute this one as well. Okay, now over here what I'm doing, if teacher tokenizer dot pad token is none, okay, if padding is not there, then we are going to be add that is specific token. Okay, so if teacher.tokenizer.pad token, if there is no pad token, we are going to be add this US token. Okay, this US token, this will be required. Now after that guys, here is a configuration for the bits and bytes. Okay, so this is a configuration for what? For the post training quantization. So if I want to be load the huge model in a smaller configuration, in that case, this configuration would be required. Right, so this quantization concept we'll learn in the upcoming session, and for sure I'll show you with the LoRa, QLoRa and all, everything will come in the upcoming session. So here we have bits and bytes configuration. We are going to be load our model in a 4-bit. Okay, so here you can see BNB bits and bytes 4-bit computation data type torch.float. This was the original one. Okay, and when we are going to be loaded in a 4-bit. 4-bit means what? So 4-bit basically it will be a 1 byte is having 8-bit. So 4-bit means half byte, 0.5 byte means we are going to be loaded in a int, right? See how much we are going to be reduce our precision. So this all the thing we discuss, don't worry. So as of now guys, I'm not going to be take this quantized model because we have very less data, and with that we were getting some issue. Means we are able to train the model, but we are not getting that loss value and all accurately over there. So what I will do, I'll load the AP16 model with the AP16, okay, with the float point 16 precision. Now one more thing guys, if I'm not able to do as of now, if I will get any memory out of error or something like that, then I'll leave this thing as it is. I'll just give you the overview, and later on you can try it out from your end, right? So here is my BNB configuration, bits and bytes configuration. This is my teacher model, and here is my teacher model. Okay, so this is the normal model without the quantization, okay, which I'm going to be load. So let me execute it. Now here I can what I can do after loading this particular model. See, this is going to be load, but it is saying auto model casual LM is not defined. So first of all, let me import auto model for causal LM. So here this is perfect. Now let's see whether I'll be able to do it or not. Maybe I restarted the session, that's why it was not coming. So this is perfect, this is fine. Tokenizer is very well, like tokenizer is also perfect. Here is a pad token, this is also perfect. Bits and bytes and all we are not doing. So now let me execute it. I think this time I will be able to execute it. Yes. So my model is getting load. Now what I will do guys, I'm going to be evaluate. I will set my teacher dot eval. Okay, and then I'm going to be set false over here, because I no need to perform the training. Okay, I will just keep this model at a evaluation mode. That's it guys, right? So here teacher dot eval. Now what I'm doing here, see, auto model for causal LLM from pre-trained. Okay, and here this is my student model. Okay, the smaller model. So let me execute this one, and the smaller model is also going to be load. So it might take time. As you can see, this model is also having like around 5 the size around it is showing 5 GB. Okay, with respect to the safe tensor file. So in quantization, you know what we are doing? We are going to be like convert the safe tensor file in some other specific extension, GGUF, GGML and all. Okay, so that's a very interesting thing and very important topic as well as the complex. So for sure, I'll show you that. So it's going to be load. It might take some time, and I'm getting like that feeling that I will get an out of memory error. So see, right now, right inside it is getting corrected also. So I'll be able to load the student model. Let me give you the overview for the further code. So here is my prompt. Okay. So here guys, this is my prompt. I have a question as well as the answer of it. I have a question as well as the answer. I have a question as well as the answer. So this data, basically what I have to do, I have to train my model. Okay, I have to disguise the knowledge from teacher to student. And when I'm going to be train my student, so I will be using this specific data. And the logits and all the softmax value and all from where we are using from the student model. Okay, so here is my prompt guys, and then after this is the configuration, the further configuration. As you can see, temperature would be there, alpha soft. Here is my cross entropy loss, this is my KL divergence loss, here is my optimizer. Right now what I will do guys, see here, I'm going to be load the tokenizer, teacher model and the student model. Then here I'm going to be set my teacher model for no training. Then I'm just going to be fetch out the softmax value. Okay, then here I'm going to be take a softmax value from the student, but yeah, I'm going to be perform the training with respect to the student model. See here I'm setting to torch.no grade, means no gradient, means regarding the teacher model, training will not be required. But if talking about the student model, so yes, we are taking a soft loss. Okay, after passing the input, then here you can see, here is a hard loss, here is a soft loss. Okay, these are labels. This one is a label. Then further we are going to be calculate the loss. This one, soft loss and hard loss. Soft loss basically using the KL divergence method. Hard loss basically using the cross entropy. Then here is my complete loss, final loss, and this is the trading, right guys? So once I will train guys, I will be getting my dislike model. See, before the session itself, when I was executing, I was getting out of memory error. So this is the entire code you can try out from your end guys. You can delete this runtime and then you can check out. The process is going to be same. Data basically I shown you, I given to you. And in the near future classes, again, we'll see couple of example. But guys, this particular example, you have to try from your end. I will give you the code. I'm getting out of memory error because I don't have access of the Collab Pro. Once I'll get it, I'll show you that. Don't worry. Now, let me discuss couple of more points. So, some theoretical point is still remaining. Okay. So, let me discuss those specific point and then I will conclude this session. I spent around 1 hour, but yeah, it is worth to invest. Now, the next point is fine tuning versus distillation, guys. So which one is great? Whether should we go with a fine tuning or should I proceed with the distillation? So now guys, see, I written all the differences. Apart from that, I given you the training procedure of the DeepSeek as well as a couple of link where you can check out with respect to the DeepSeek training and the entire distillation process and all. So I kept the distillation, the mathematical concept of the distillation with respect to this DeepSeek because it is a state-of-the-art model, and I intentionally kept this particular model itself. Okay, so let's discuss the differences, and after that I'll close this session. So guys, the first is the data source. Okay, so if in the normal fine tuning, what we are doing, we are going to be take the dataset label only. Okay, and we are going to perform the supervised fine tuning with respect to that specific data. But if we're talking about the distillation, in the distillation, we are taking a dataset label as well as we are taking teacher soft output. I think you know about the soft output. It is a softmax probability. And I think you are aware about the loss function also. It's a combination of the KL divergence as well as the cross entropy. Goal to make a model task specific. Now here the goal is to make a mimic of the teacher model. Okay, we are going to be create one student which is a mimic of the teacher model. Output info, one hot labels only. Here full probability distribution, software large, so softmax values basically. So the final output we are getting the one hot encoding. Before that we'll get a softmax, but this will be my final output. Now here in the output we are getting the basically softmax probability. Okay, then later on we can convert into the hard level for predicting the actual value. Model size same as a starting model, and it might increase also. Teacher is large, student is small, as I shown you. Okay, result wise, model is trained for the task, for the specific task. Here, a small model that behave like a teacher. So whatever teacher can do in a same way, smaller model also can do. So the idea of the distillation is very simple. Let's say we have a very huge model. I can take this GPT for B. Okay. So how we can utilize the knowledge of this model in some small model? That's a real use of the distillation. Now, normal fine tuning means what? We have a model, we just train it on some data and we are using that. That's it. Okay. Now, in short, fine tuning, what is the meaning of the fine tuning? The model learns the task only from the data, and distillation means what? The smaller model is trained using both the data as well as the teacher understanding. Okay. So here, when to use normal fine tuning? So if the model you plan to deploy already enough for your latency, memory, budget, and you have labeled data, what is the meaning of it? So the model which you are planning to train, right? It is you are having enough memory. You can basically bear that latency which you are getting with respect to the data while you are training or after the training with respect to the use model. If you are getting a latency in terms of the prediction, if you can bear that with respect to configuration and all, okay, then you just need to fine tune your model. The data set is large and clean if you don't have a restriction of the GPU memory and all. Means if you have a good data, if you don't have a if you have a task specific requirement, okay, and if you don't have a constraint of the GPU and the memory, in that case this normal fine tuning is a good one. But guys, if you're talking about the knowledge distillation, when it is best, so if you have any teacher model and the teacher model is a very large, and you want to be like want a fast or small model which is going to be mimic similar to the student teacher model. In that case, you will do the distillation. So in simple, I can say normal fine tuning means task specific model, but distillation means you have a big model. You just want to be create a copy of that. Getting my point? I can explain in a better way. Let's say we have a father. Okay, now father is doing something, son is doing something. Okay, father is doing something, son is doing something means what? Some son is doing some specific task, their own task, because it has trained on some specific data. That's a normal fine tuning. But if father is there and son is doing similar to the father, okay, that is a distillation, right? Now here you can see. So the other one, the data set is a small. Okay, the teacher soft label is provide you the extra information. In that case, you can go ahead with the distillation. You need a lightweight model for the deployment. In that case, you can choose that this distillation like mobile app, edge devices, a low latency API and all. Or you want a copy of the teacher reasoning. In that case also, you can choose the distillation. Now, how's the performance? So distillation usually perform better when the teacher is strong because the student gets a richer training signal. With normal fine tuning, the student may generalize less, especially when the data is limited. Okay. So I hope you are able to get this 2 point also. Now, short answer, if you just need to train one model without a teacher, normal fine tuning is enough. If you don't have a constraint of the GPU and all, if you want to have like a specific task related model, if you want a smaller, faster model that perform like a teacher, then distillation is better. In industry, we follow the both combination, means we fine tune the model, okay, as well as we perform the distillation also with respect to some good model. So hybrid approach is also good. Now I hope you understood this entire thing. Now let me discuss a couple of more points. Then I'll close this particular video. So guys, in the starting, I shown you a few points then where we have to use the distillation. So let's discuss those part as well. So here I kept a couple of points with respect to that. So distillation we have to use for the small devices. If we have a small device, in that case, we should go for that. So I written a point where to use the distillation. In LLM as well, Distill GPT, Distill BERT to compress heavy GPT and BERT model for the faster inference. If you want a faster inference with a limited configuration, in that case, we should go with the Distill GPT, Distill BERT. We should display the knowledge of the huge model if we cannot load a very larger model. The second one, basically smaller and faster inference, the same thing. If we want a small model, the fast inference, we should go with the Distill model. Okay, and retain accuracy, that whatever teacher is doing, if you want to do with a small model, in that case we can go ahead with the distillation and we can utilize it. Lower serving cost means if we can load our model on a lower infrastructure with the same capability like the bigger model is doing, in that case also we can go ahead with the distillation. Ensemble learning means if we have not only one model, if we want a combination of if you want a learning from combination of model, we can do that also. So let's say we have a 5 large model, and if we want to mimic, if we want to be transfer the knowledge from all the 5 model into the one single model, in that case also I'll choose this distillation, right? So this is all the point, guys, which you can simply explain in the interview, and your interviewer will be very happy with you. Now coming to the next part. So here, guys, I kept few more points. So if we're talking about the DeepSeek, guys, right? So the DeepSeek is an open LLM initiative. The DeepSeek was having the base model. The base model is called the DeepSeek V3, and then further they have trained the DeepSeek R1. Now we are talking about the DeepSeek R1. So from the DeepSeek R1, they have distilled so many models, guys. Okay, so here you can see they distill R1 to distill a small model. So many like model you will find out with this from this DeepSeek R1. Okay, which they have distilled the knowledge from DeepSeek R1 to the different other model. So where you will find out all the model, I mentioned couple of link. You can go through mainly with this Hugging Face link. Once you will open it, once you will click it, guys, so here you will find out the DeepSeek R1 repository. Now once you will explore down inside this repository, you will get all the models which has been distillized. So DeepSeek R1 distill coin, okay, there's a coin, llama is there, okay, llama is there, and you will in the Hugging Face repository itself, model repository, you will find out hundreds of models which have been distillized using this R1. This is some official model which was provided by the DeepSeek itself. Okay. Now I hope you are clear. So I will create one more series with respect to the DeepSeek, and for sure with that your understanding will be more clear with respect to the DeepSeek. So guys, here you can see if we're talking about the base model. So base model is a V3. Okay, this model actually it's a sparse mixture of expert MOE model. Right, and here you can see it is having a reasoning capability, means further it has been trained. Okay, supervised fine tuning have been performed. Then RLHF with a GRPO technique, which is a variant of the PPO technique only. All right, then RLHF2, right? So this is the advanced training which was performed for the DeepSeek R1. That's why it is very good model. If you will check with a different leaderboard and also somewhere you will find out there's a specific model. So distillation, yes, R1 has been distillized further. The knowledge has been distillized in many small model, and those model is doing good. Okay, similar to the this DeepSeek R1. Now here guys, you can see I have mentioned couple of posts. Inside those posts you will find out the complete detail, like how the DeepSeek V3 have been trained, and how basically R1 is created, and then how they have used the capability of the R1 to distillize the different model. So this Medium blog, I will suggest you this Medium blog where all the like the complete process have been mentioned. Okay, with respect to this DeepSeek R1 distillation, right? How, see inside this blog you will find out the complete explanation of the DeepSeek distillation, and inside this particular blog you will find out how DeepSeek R1 have been distillized further for the 5.3. Okay, in 5.3 also, in 5.3 mini model also, some knowledge have been taken from the DeepSeek R1 itself. So this both you can follow this two Medium blog and this Hugging Face for reading the model and all. But in the upcoming video, I will explain this entire thing in a very detail, because in my mind I have that to create one like LLM series from scratch, from transformer to the Bert GPT, then different transformer based model, multi-model, okay, images, audio, generate image and all, everything guys. I want to be covered on the ground level so that your understanding could be clear, and that only I will discuss about this DeepSeek and all. So yeah, I hope you like this video. It is quite long, but yeah, it is full of knowledge. And after seeing this two video, first part of this distillation and the second one, you won't feel lag with respect to the distillation. You can understand any sort of a concept of it. So yeah, thank you. Bye bye guys. Take care. I'll see you in the next video. Until, thank you. Bye bye. Take care.